Hello everyone, this is Bradley. So today this is a tutorial talking about the fake hair physics animation that I've done several days ago. It was inspired by an animation I've seen on Twitter. You can find the reference from the link in the description. In this tutorial, I'm going to use Blend 3.1, but you should be able to follow that in 3.0 without many problems. You will need to do some workaround if you're doing this in 3.0, but this workaround has been mentioned elsewhere already with my tutorial, so I'm not going to repeat that. The reason I'm going to use 3.1 is because even if I use workaround and teach you in this particular tutorial, it will be very quickly irrelevant several weeks later. So let's start. So here in Blender, as always, I'm going to use the presets I made for myself, so you can download them for free from the link in the description. So we start with a curved circle, and usually my next step here within my tutorial is I add a bevel curve so that you can visualize better. Also, we have the thickness. Actually, we're going to achieve the same results. However, maybe in this particular case, using this preset is not really benefiting us, so I'm not going to use these presets. Instead, I'm just going to replace that with the native geometry nodes, so that I need 2 nodes so that I create this kind of thickness. So here I'm using 2 nodes to replace 1 node, and I actually need the UV map as well. So let's take a curve parameter. No, actually in 3.0 it's called a curve parameter, but we cannot find a curve parameter anywhere because it has been renamed as a spline parameter. This is why I would like to do tutorials within 3.1, because even if I teach you that, oh, let's use a curve parameter, then goes to 3.1, you realize, hey, there's no curve parameter node anywhere because it has been renamed. So now we have about 5 nodes to replace this 1 node because this is a UV map actually. Okay, in this case, the reason I'm going to do this is because I would like to distribute points. And I'm going to increase the density. So now all these kind of points are evenly distributed along this circle. But there is one issue that you always need to realize is that finally when we are trying to instance the hairs, because this area is larger or more loose, so it will be visually looking like less hair being instanced outside compared to inside, while this is technically speaking a even distribution. Okay. So to resolve that, I'm going to deal with some math with this spline parameter. The spline parameter is basically starting from a curve. The start is 0, the end is 1, and it goes around with a circle. Okay, and the second curve parameter is basically for the thickness. Okay, still 0 to 1. So in this case, we're going to use the second curve parameter for the moment. I'm going to add a math add. And I'm also going to add a modulo. So modulo at 1, it means all the values will be looped between 1, no matter how you add some values. And let's add a color ramp. And let's take that into the density, so we can crush the color ramp just for better visualization of the actual effect. Right now, because the density is very low, so you do not really see anything. But by adding a map range, and you can see the effect immediately, that previously we have an even distribution of all these kind of points along this entire donuts. But now you can see only the bottom part has instances. And this is the magic of this kind of curve parameter manipulation. So we can doing a kind of math so that you can see there are more points instance outside than inside. So here, let's just increase the maximum, maybe 100, and make the minimum instancing a little bit, so that later it will be more visually appealing when we have the hair instanced on it. So next step is basically to instance our hair. So let's just get a point instance. And we're going to instance our hair, so let's get a preset which is called curve linear. Curve linear is basically just a curved line with some resampling. So I'm going to make it erecting up and delete this center. Turn down this value a little bit. and you can use the count to manipulate how many sampling of it. And in this case, we're just going to plug the rotation into place. So now this is our hairs. So remember, this kind of two parameters essentially drive the amount of instances you have. And in this case, you may just decide a ratio between them and add a new math node and to multiply the density so that you can increase the density more easily with a single parameter instead of two. Okay. But this is just something that we will deal with later. For the moment, I do not want to deal with so many particles, so let's just take 0.1 so that we get a kind of rough idea how things is going on. Next thing I'm going to do is to actually displace this point. So we take a set position and we add a noise 3D and plug the colors into offset. Right now, we do not really see the displacement on each of the points of our curve because we do not have access to these points without realizing the instance. So we realize the instance, so immediately we can see this kind of displacement of our hairs. You can increase the scale, but you also realize that those curve points are completely displaced beyond the surface that they are spawned initially. So in this case, we can, firstly, I need a joint geometry so that we can have a reference of the starting points in which we're trying to curve to mesh this entire object. So you can see our hairs are not on the object. So the reason is simply because we're displacing the starting point too much. So what we can do here is basically still vector math to scale with a spline parameter. Again, if you're using 3.0, then you call that curve parameter. Okay. So now the starting point will be 0, the rest of the point will be displaced. You may ask, hey, Bradley, you just made a scale options here within the noise 3D, but why do you add another vector mass node? This is simply because I want to have another control of the scale of how this noise behave. So sometimes people think, using a preset within a tutorial is really not helpful for beginners to learn, but in reality, it's just an additional vector math node. How difficult is this? And you can increase the frequency or decrease the frequency or whatever. You can also even evaluate this noise, but that's another story. I'm not going to cover it in this particular case. Yes. Okay, just to make it a little bit smoother. Okay, so once we have done this, I'm going to do a little bit of distortion because the end goal is actually to bend all these kind of hairs. Okay, so maybe you can use another set of position or you can use the original set of position, but whatever ways you're going to do, I'm going to vector rotate that. So when you add a vector rotate node, immediately you lose everything because you need to recall the position attributes, and then you can try to rotate these kind of points. Okay, but right now all these kind of points are rotated at what coordinate, so we need to make them local. So this is the part in which 3.1 really makes your life very easy because you can capture attributes in instance domain. Okay, so you can capture the position attribute. So you just take the position attribute. Actually, we can use the same position attribute. It does not really matter. Okay, in the future, I will release the preset which contains the attribute instance, so you can directly use the position there. It's basically the same function. So use one node to replace two nodes, kind of idea. Here we just use the attribute to center. I've talked about the attribute to instance in my other tutorials, so I'm not going to repeat it here if you're using 3.0. But just to know that no matter which workaround that you're using in 3.0, these are no longer relevant in 3.1. Okay, so now this is kind of local. Then you can see at least they're bending around their own origin, but it's still not really local because it's still x, y instead of local axis. So in this case, we're going to construct local axis and the rotation. Instead of using the ULA, I'm going to use the axis angle. it's a little bit difficult to explain axis angle, and I do not want to really explain it in this particular one. So you can try to understand by yourself. Actually, just by manipulating this value, you can realize if my axis is 0, 0, 1, which means this is a rod here, and I'm rotating all the points around this rod, then you get kind of an idea about how this is actually function. Here, I'm going to use actually a math function, even though I'm not very good at math. I'm going to capture the tangent and normal of our curves so that we can construct a local coordinates. So here we need to capture a vector attribute because the curve tangent is a vector. Okay, curve tangent is basically following the flow of our curves. So for example, this direction, that direction, and that direction. Okay, and the normal is always facing outwards of the curve. Okay, but we're going to neither use this curve tangent or normal. The reason is because we want to achieve the effect similar like this kind of z-axis rotation. So this is the z-axis. But right now, the axis is obviously not perfect because we can see, despite all this kind of horizontal one, which is rotating very well, the other one is still straighting up without any rotation. Okay, so we would like to create a kind of cross product. The cross product is when you have this kind of two vector on this x, y plane. Then the cross product will be the one which is shoot up. Okay, so you can add a vector math node, and you have a cross product in this tangent and normal. But this also comes to a problem that once we are trying to make this as a donut, the curve, the tangent is still tangent, but the normal is no longer normal because the normal for this particular spline is facing this direction instead of that outwards direction. So we need to use other normals. So we still need to use the tangent. So we keep the tangent, but we need to use another normal. And this normal is very easy to find because we know this normal is the one that's used for instancing. So we construct these two cross products and plug this vector into the axis. So immediately you can see this kind of perfect rotations. And we can see, so all these kind of points are looking that direction, that direction, that direction. So they are following these entire curves perfectly, okay, without any kind of problem. So just to remind you again with this concept, that we are capturing the curve tangents from our most initial curve circle, and then we are cross product with the normal from our distributed points on face and plug that into the vector rotate. Okay, now we have this kind of good rotation, but it's not really looking like a kind of bending effect. So we simply just take the curve spline parameters so that it makes it curve-like. And in this case, if we are using a math node to multiply with these values, so at the value 0, it's straighten up with just kind of a noise. And then you can see by multiplying the value, we're having this kind of bending effect. Okay. You can make this bending sharper or looser with the float curve nodes. And you can also increase the resolution of our curve linear so that it may be more smoother. Or you can play around with this kind of frequency so that you add more noise. You can even add a new set of position and use that position so that you're bending the noise at the same time. So there are lots of ways to manipulate this thing. There is no single right answer. Finally, it's your choice and your decision. Okay. Once we know this effect of this multiplier, we just need a trigger so that this bending is only restricted to a certain area. Okay. And to make a flow through of this entire torus or donut, we basically use the concepts as we have done earlier with this add and modulo. So we duplicate this one and use the first value that we captured and we plug these values into the multiply. And you can see by adding these values, you can see a kind of effect, the bending and straightening effect. This looks kind of very ugly and abrupt because at the end, this kind of spline parameter is going 0 to 1 abruptly over a circle. But if you're considering the real bending effect in real life, then this does not only bend, but it also recover. So we need to take a color ramp and make the values 0, 1, 0, things like this, so it can be more kind of smoother. Okay, but obviously this is just an example. Okay, so in reality, to give a better control, I'm going to use the curve, float curve. Okay, the reason to use float curve is because you can map the interpolation like you are mapping the graph editor. So here I'm going to add a map range. So remap the 0 to 1 to -1, 1. The reason I'm doing this is because by default it's clipping, and I do not want to manipulate these values since these are not accessible outside, like the group inputs and the geometry nodes. So I want to use the map range. And here, let's just put all these kind of values to the midline, because I essentially remap them to -1 or 1, which means the midline actually means 0. That's why they are all straight. Okay. However, if I try to remap the values, so like this, then you can see some of the splines is rotating in that direction. Some of the splines is start to rotate in the other direction. Okay. So this is this direction, that is the other direction. And this is essentially affected by this curve parameter addition. Okay. So here what we're going to do is we're going to extend horizontal, so that we're trying to restrict the movement so that some of the place is still staying at 0. And then we're trying to remap like we're doing the keyframe with a kind of overshooting effect. So now if we can try to see, so you can see there's some of the splines bending, and later they recover, and then they goes back to straight status. This is essentially how you kind of fake the effect. And you can try to play around with this kind of value and addition. Okay, so this is cool. And finally, knowing that this amplitude is determining how much you bend. Okay. So you can add a negative, so that you use one value to control 2. So you add a 1 or 2 so that you can control the strength. Or actually, you can actually add a math nodes behind to control the amplitude. But that's another story. I'll just make you to decide how they behave, essentially. Okay. The last step is not very important. We basically generate some context of this animation instead of all these kind of splines bending by themselves without any trigger. So we start with a curve circle. Take a bevel curve, generate the thickness, and finally transform this curve. In this case, let's just align on spline, because I need a sample curve. I've explained this sample curve node in my other tutorials, so you just take the position and the translation. So there is a red lines, but you can see it's actually working. I want to call this as a bug, but yeah, anyway, it's just there while it's working. So what else I can say? And by playing with this factor, then you can try to move this torus or ring. So here, let's just join geometry. There is one kind of issue with this factor, that it only works between 0 and 1. So what you need to do is to add a modulo function. But the modulo function also has one kind of issue that if it goes to negative value, it will still be clamped at 0. The reason is that this modulo is actually outputting a negative value if your value a is negative as well. So in this case, we're actually using fraction. Fraction is basically modulo at 1, but it will not copy the sign. So which means even if your value goes to negative, it will just work as expected. In fact, we should always use fraction in this case. And at last, we just synchronize this kind of values. So let's take a group input and add this value. So right now you can see there is an issue that the bending is to in that direction, the flow is to in that direction. So we need to actually reverse them using a negative. So one is using the negative value, one is using the positive value. Okay, so now they are flowing in the same direction, but with a little bit different offset. So we're going to add a little bit of offset just using a new mass node, just to align them a little bit better. So now you can actually see the effect. This is how it looks like. Okay, I'm not going to talking about color in this particular tutorial because it's kind of simple thing to cover. Finally, it's just set curve radius with the spline parameter and map range that to reverse something like that, decrease the radius, make it more like a hair. So by the end of the day, it's just the amount of instances that you need to actually create. Okay, this is not really a very difficult to set up, but it looks kind of many nodes. The reason is that there are tons of regions that I do not use presets. Maybe I should create a preset someday for this kind of functionality, but that's another story. What I haven't discussed is about randomness in many other parts, for example, random size, random length, and other things. But this tutorial is already going to be long. Actually, my throat is already burning out, so I do not want to continue this anymore. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye-bye.